Okay, welcome to the St. Louis Jobbers Group for January 9th. Um, as we were an informal organization, um, and we don't keep a list of people that attend, but our first meeting was back in May of 1997, shortly after Java was launched. Our attendance is free, no more membership list. Normal meeting date is the second Tuesday of each month, except December when there is no meeting. And I'll have to admit, next month in February, we're going to have the meeting on February 20th. We'll be on that second slide. I'd like to introduce the steering committee, which controls the drug. From left to right, that's Zach Klein, myself, Robert Levitt, Wei Shake Gao, and Bruce Hossbaugh. Thank you. And thank you very much. All right. We'd like to thank our sponsors here at this point. The first is Object Computing Incorporated. We're meeting in the training room tonight. They're one of the founding sponsors of the jug, and they really do a lot for us, including the past. They had the host of the webpage for us. Tech Systems is a recruiter, so if you're looking for a job or looking to hire Java programmers, you might go by them and see what they're doing. JetBrains is a wonderful place where they make wonderful IDEs, and we were offering off 2 JetBrains licenses or 4 actually this month. I apologize, since we're here in December, we've got the December ones we were giving away in December to give away here now. And they're for a single IDE. So if you have JetBrains, you might, even if you have IntelliJ, you might get one for another language. And next speaker is Manning. They're a book publisher. They're very gracious and allow us to give away 2 free ebooks each month. I guess you must be present either in the here physically or in the Enterprise Mobility and Oracle are both both sponsors who have been here in the past. And the Enterprise, it does have a couple of positions for Java programmers here in St. Louis. Next slide. Okay, announcements. There's a jug discount for Manning, jug 13 for 40% off any Manning product. Dev Nexus will be March 4th through 6th, 2025 in Atlanta, Georgia. And there's a place to register. And then there's no fluff stuff. If you notice that the super early bird special expires tomorrow, January 10th, we've got a code JUG1 NTFS25 to get you to $100 off. And they're going to be here in St. Louis at the Marriott West. And there's a URL, nofluffjuststuff.com/St. Louis. Okay, our upcoming presentations on February 20th will be on May 4 by Chandra Gunter of the New York and New Jersey, Garden State Jugs. March 13th, we're going to have an all-code introduction to domain-driven design and hexagonal architecture by Jeremy Davis at Red Hat. And tonight, we have another, if you want to keep for upcoming presentations, please go to our meetup page. Gateway is our Gateway Jug is the name of our jug on there at meetup.com/Gateway Jug to see updates on presentations as changes may come from time to time. And past presentations are uploaded to YouTube, and you can go to that link and see where it is, or just go on YouTube or just search in YouTube. If you're interested in getting a presentation sponsoring one, please send an email to the steering committee at our address there. All right. And then our meeting tonight is a holistic software architecture by Marco Carducci. And hey, he's a magician, and holistic software architect. And he's got a book coming out in the next couple of months, I believe. So Take it away, Michael.
All right. Hey, thank you so much. Give a round of applause for Ted and everybody putting this event together. I am delighted to be here with you, and we're going to talk a little bit about software architecture, and I don't know, we'll dive in, but definitely I'm happy to be here tonight. I'm going to be back for the No Fluff Just Stuff event in April. Definitely a great event. We, you know, instead of the big events that you fly to, with the great speakers and the great content and everything, we just bring it here to you with No Fluff Just Stuff. And thank you for the introduction, by the way, Ted. My name is Michael Carducci. I've always had a challenge explaining what it is that I do for a living. In fact, just recently, around the holidays, talking to my dad, my stepmother, catching up, the usual holiday conversations, and got to the subject of work. How's your work going, Michael? My stepmother said to me. I said, oh, it's going good. She said, are you still fixing computers for work? Yeah, I'm still fixing computers. But it's a little more than that. I do a lot of things. Ostensibly, I'm a software architect. I'm an independent software architect. I try to be hands-on. I feel like an architect who doesn't code is like a chef who doesn't eat. But beyond that, I've started calling myself a holistic software architect because most of the time when I come on for any kind of client engagement or anything else, I found out that I do very little software architecture because the challenges that they're running into rarely originate from the architecture. They're just looking for architecture to solve it. And just like code, we can throw code at the problem, but it's very rarely does that kind of solve the root issues. We're just sort of building on top of a faulty foundation to begin with. And that this whole idea of taking a more holistic look at software architecture, taking the fragmented models and patterns and things that we have, unifying them, making them more practical, making them more actionable, and making software architects more effective is really what I've been trying to do the last 7 or 8 years. That's culminated into this book, which is coming out in March, and I'm going to put a pre-order in. We're going to raffle one out. So if you win, I'm just going to put the order in, and as soon as it goes live on Amazon, it's going to ship to you, as long as you don't mind sharing your address or wherever you want it sent to. I mean, I guess we could send it here if you want to keep your OPSEC solid, but we'll figure that out. But let's kind of dive in. And everything that I've been doing in the software architecture, the space, the last several years, the last 2 years, writing this book, trying to formalize this model, really kind of started with 2 foundational assumptions. The first one is this idea that, I can be better today than I was yesterday. And the second one is that our field can be better tomorrow than it was today. Now, the first one's easy to accept because everybody who's here, whether you're here or whether you're here, you're learning, you're growing, you're investing in your knowledge portfolio, all of these kind of wonderful things. But the second one is more challenging because we're surrounded by all this conventional wisdom. And not only that, however advanced we think that we have gotten over the last few decades in software architecture, the discipline itself is fairly young. We didn't start, I realized to my horror that I am older than software architecture as a discipline. As I started doing a lot of the research for my book, it kind of stunned me. The first time we really started thinking about it, before we had a label, before it became a discipline, probably goes back to the 1970s. Maybe one of the earliest works where we start thinking about more abstracted away from the code was a book in 1976 by Frank DeReamer and Hans Kron, and it was called Programming in the Large versus Programming in the Small, basically realizing that different contexts require different solutions. But we didn't start thinking about software architecture as a formal discipline until the late 1980s, and the very first book with an emphasis on software architecture came out in 1990. This is my copy, Application Architecture, Modern Large-Scale Information Processing by Lawrence Best. And there are a lot of other ideas that were kind of popular at the time. And one of them was kind of building on this idea of what they call the software industrial revolution, that we could build software out of these kind of composable building blocks, and we can assemble them this way or assemble them that way. And back in the 1980s, there was a guy named Brad Cox. And he got so excited about this idea that he made a bold statement. This paper came out in 1990. There is a silver bullet. And that was a direct, almost like middle finger up at, why am I drawing a blank on the guy's name? Fred Brooks. Fred Brooks, who wrote No Silver Bullets, Accident and Essence in Software, fantastic paper. And The Mythical Man Month, that was in the 1970s, another great book. And I think Fred Brooks won a Turing Award or an ACM Award or a Turing Award or something like that for Accident and Essence in Software Architecture. But he said there are no silver bullets. And Brad Cox came out and said, there is a silver bullet. Of course, he walked it back. Any reprint, any subsequent publication of this paper or this essay, he walked it back, and the subsequent title was, What If There's a Silver Bullet? I think he got a lot of flack for this. What if there's a silver bullet? And unfortunately, the silver bullets are hard to come by. And it's, when I look back on my career, I've been primarily in the software architecture sort of space for a little over 15 years now. I've been in the tech industry for about 25. And I realized that no matter what we figure out, no matter what we invent, no matter how many novel ways we've come up with to put software systems together, or take them apart, which is another thing we love doing, that there's still these challenges that keep emerging over and over again. There's the cart before the horse anti-pattern, the out-of-context trap. There's a problem with our taxonomy of software architecture that is doing us a tremendous disservice. And not only all of that, even if you can figure out the right thing to build and design it, people have to go and make it. People have to follow your blueprints. And they've got their own ideas, and they've got their own agendas, and they've got their own priorities. So that's another challenge in the people problems in architecture. But what it really boils down to is this idea of a lack of architectural fit. Now, when we survey software architecture today, so much of the literature is very pattern-focused or topology-focused or technology-focused or communication-focused. But if you look at the state of the art, we've got maybe 8 or 9 patterns that show up over and over and over again. And to some people, this is software architecture. But I disagree. This is a side effect of software architecture. Patterns aren't architecture. They're just a side effect. And the more I'm in this field, the more I realize this is true. And when we go at it from the wrong direction, sometimes we succeed. But more often than not, our software fails to live up to the ideals and the potential that we try to build into it. And not only that, I was at one of the No Fluff events some years ago, and I was sitting in a session that was run by a guy named Llewellyn Falco, a really interesting guy. And part of his session was to do a joint kind of a group coding exercise. And we were going to express intent in one line of code. And he says, how can we express this in code? Of course, everybody's like, well, what language? Are we doing in Python? Are we doing in Java? Are we doing it in C#? Nobody's talking to you. I kid. I do a lot of work in the .NET space. Nobody's perfect. But so we choose a language. Most of the people in that space were Java folks. So we write that line of Java. And he says, great. How else could we express that? And suddenly I look up and I see there's a timer on the screen, and it's counting down from 15 minutes. It's like, we have 14 minutes and 30 seconds left. We just did it. He says, yeah, but how else could we do it? And we fought for about a minute and a half, and we came up with another way to express that same intent with vanilla Java. And he says, okay, great. How else could we do it? And now we were all stumped. We sat for about 4 minutes thinking about it. And then we came up with a third way. And he says, how else? And this time, it didn't take longer. It took less time. It took about 20 seconds. And then he says, how else? How else? How else? And by the time that timer ran out, we had come up with about 40 ways to express that same intent in a single line of code. And we weren't slowing down. We were speeding up. And that left me with an unshakable conclusion that there is a near infinite number of ways that you can write code to deliver a set of features and functions. And of course, no, they're not all created equal. Some of them are going to be more efficient in terms of time or complexity, but it does little for the attributes of the system as a whole. And so what that means is if you give me a set of requirements, you say, hey, Michael, I want you to build a software system for us. Here's all the requirements. I can build that system using any of these patterns. But some of those will be more successful than others. And so that might lead one to a conclusion, okay, we found the best one. Except that's not true. That runs counter to the very ideas of software architecture where everything is contextual. Now, I think it's interesting because now that I've spent the last 2 years writing a gigantic book on software architecture, I've really gone deep into all of these and traced them all back down to their roots. And it's interesting because each one of these patterns that we know of and all the little variations and everything else, they just came out, they emerged as patterns when we started seeing, hey, you know, if we take this approach, it kind of works in this context or that context. So some of them emerged just from a desire to have your code better structured, maybe kind of break it apart, get away from the big ball of mud. So we had challenges around organization of the code and understanding the code and maintaining the code. And then as the technology ecosystem evolved, we had new challenges. We were building client-server software. That's where I started out in my career, building pretty simple monolithic client-server applications back in my day. And I'm getting old enough that I can talk like this now. You know, shipping software literally meant shipping it. Sometimes we would have to send a master off. That was stressful. And other times I used to spend, I worked for one company around 2002, 2003, around there. And every summer, we would spend the entire summer on client sites, going around the offices with a visitor's badge and a floppy disk, installing software on machine after machine after machine. But we got new challenges with client server. And we realized, hey, there's different things in here we can optimize. And then as more and more software moved onto the web, we realized that, okay, we need to start thinking about scale. Because when I started out, the software that I built supported an office. And now we have software that can support the entire planet. We can build software today where the entire planet is a potential user. So we had to think about that kind of scale. But something else emerged. We discovered very quickly, and some people discovered the hard way, that when the entire world can be your customer, the entire world can also be your competitor. So if you can't keep up with changes in the market, changes with technology, if you can't be agile in the way that you deliver your software, somebody somewhere will, and they will eat your lunch. And so all of these patterns, it turns out, they just have different strengths and weaknesses. And this is because these patterns emerged as solutions to different sets of problems. Now, some of these, that one, was more of a product of its time, but it doesn't make them irrelevant. They still have lessons to teach us. So all of these emerge as proven approaches to imbue certain capabilities into the system. And these are the capabilities that drive software architecture decisions. And so this is how I think about software architecture these days. Software architecture is the essence. Architecture is the essence of the software. It defines everything the software can do beyond the defined features and functions. And so each of those patterns give us different capabilities, but we have to take a more mindful approach. And so as I started trying to unify the fragmented models of software architecture that exist today, I realized that I gave the whole thing a name, and this is why I think on my title slide, if I jump back to that for a second, I have this illustration. I've got this illustration of a suit jacket under construction on a tailor's form. Because whatever the architecture is, ultimately it has to fit. And you know, there's a whole long side story about how I had a brief career in men's haberdashery. And so the model itself that I'm going to talk you through is nothing really new. It's just putting things together in a way that can make us more effective. And I called it the tailor-made architecture model. How do we come up with software architecture that fits? And how do we tailor that fit over time? In the same way, I have a suit in my closet that I bought 15, 16 years ago, something like that. Now, that suit hasn't changed, but I have, for better or for worse, but I've tailored it. And I think we can do the same thing with our software. Our software doesn't necessarily have to be, quote, the stuff that's hard to change, as I think it was Grady Booch who said that. And so one of the axioms that I started with is that architectures are not chosen. You don't choose an architecture. You don't select an architecture. We design an architecture. Now, if we choose to constrain our approach to software architecture as just picking one of the patterns that are out there, I mean, that's a decision. That's a design decision, but it's not necessarily a very thoughtful one. In other words, everything is designed, but few things are designed well. Architecture has to be executed deliberately with specific goals in mind. And the success of the design aspect of architecture depends on our ability to think architecturally. And so before I got into the, when you look at the book, I don't even start talking about this stuff until you're about 200 pages in, something like that. I don't even know where we are because before we get there, we have to be able to think architecturally. And so one of the big questions I asked myself for a number of years was, how do we improve architectural thinking? Because there are no right answers, absolute right answers that we can just universally apply. There is nobody ever got fired for buying IBM, or nobody ever got fired for prescribing microservices. There's nothing like that. It's always a trade-off. And I remember I was having a conversation with another no-fluff speaker, a guy named Ken Cousin. And later in the by the end of the conversation, he kind of got up and said, you know what, I'm glad I'm not an architect. I like being in a field where there are absolute right answers. And in some way, I envy that. But as soon as we start with the answer, before we even know what the question is, what we're doing is we're blindly walking into an anti-pattern. What Mark Richards calls the cart before the horse anti-pattern. Basically, choosing the architecture before you even know what the problem is to solve. And in fact, Mark Richards goes on to say this. He says, if you don't have the right architecture in place, or you choose the wrong architecture for a given project, generally the functionality might work, but the system as a whole won't be a success. And maybe that means it won't be the success it could have been, or maybe it's not the success. It's the kind of definition of not a success that means your project gets canceled. And so this question, this misguided question, what is the right architecture? There's no answer to this. Universally, the answer, if you've ever spent any time around software architects, the answer is always, it depends, which is really fantastic for me, but it's really annoying for everybody else. I was chief architect at a Fortune 100 financial services company, fintech. I don't know what you'd call them. I'm not going to name names, but I was chief architect of this company, and still really good friends with the director of software architecture or software development there. And at one point, we've all since gone our separate ways, but I was chatting to him and he's asked me a question, and so I flipped it around. I went all zen and started asking him questions. And he came back, he says, well, it depends. I'm trying to help you, man. Trying to be a little Socratic with all this stuff. He goes, well, it depends. And then I just kind of smirked. He says, yeah, it's annoying, isn't it? I said, yeah. And in fact, Roy Fielding talks about this in his fantastic 2000 doctoral dissertation, Architectural Styles and the Design of Network-Based Architectures. He says some architectural styles are often portrayed as silver bullet solutions that are suitable for all forms of software. However, a good designer should select a style that matches the needs of a particular problem being solved. Kind of paraphrasing Fred Brooks there again. A decade after Brad Cox boldly proclaimed there was a silver bullet. And what it means is there's no good architectures, there's no bad architectures, there's just trade-offs. It's all about the illities. Now, I don't call them illities because I deal with a lot of non-technical audiences. I have to talk to the business people a lot. And if I say illities, they just sort of look at me like I sprouted a second head. And for a while, I was calling them non-functional requirements. Oh, they beat that right out of me. Because one of the things I discovered, especially like product-centric companies, they don't give a crap about the non-functional stuff. What's the app gonna do? So they switch off as soon as you say non-functional. As soon as you say non-functional, they've stopped listening. So I've started calling them capabilities. We know what the app needs to do. What kind of capabilities does the system have? So I've been calling them capabilities ever since. Capabilities like scale, or evolvability, or adaptability, or composability. There's a bunch of them. And every time you make one stronger, that comes at a cost. Nothing comes for free. To make one stronger, you're trading something else. Maybe you're trading cost. Maybe you're trading performance. Maybe you're trading complexity. It always depends. So we have to be really mindful and really thoughtful about how we approach these trade-offs. And that's where I got this idea of architectural fit. Now, I've been involved with No Fluff Just Stuff, the conference series, for more years than I probably care to count. I think my first introduction to No Fluff Just Stuff was in 2008, 2009, something like that, where they actually hired me to do a magic show at the conference. They found my website. They're like, this guy looks competent. We'll hire him. And I remember talking to Jay Zimmerman, the founder and organizer of all the No Fluff shows. He says, by the way, your audience is going to be software engineers. They're going to take apart every single thing you do. They solve problems for a living. This is a really smart audience. Are you up for it? And I said, yeah, I think I can do okay. And I went in there, did this show, blew the, I don't have a good metaphor for this. Blew the house down. Am I mixing metaphors? I don't even know. I don't even know what time zone I am. I'm just cold. That's all I know. And it slayed. How about that? To use the parlance of the younger generations, it slayed. And as I was packing up, I could hear people talking, wow, this guy, where'd they find? He really did his homework. He was making jokes about cucumber tests. That's a deep cut. They didn't know what my day job was. But it was so successful, he hired me to do another show at another conference a couple months later in Florida. He says, hey, you want to do the show again in Florida? I said, you'll fly me there? He says, yeah. When is it? December? December in Florida sounds a whole lot better than December in Colorado. I'll take it. And so I flew out there, did it again. And before I knew it, I was the resident magician on the No Fluff Just Stuff tour. And I think it was about 3 years of this before Jay finally took me aside and said, I think you know more than you let on. I said, maybe. You never asked. Have you ever thought about speaking? I said, no. He says, think about it. I said, okay. I thought about it. No, thank you. One talk, and here I am. I actually just looked at the schedule for UberConf in July, the big flagship event that No Fluff Just Stuff does every year. They have me down to give 17 talks. Each one of these talks, by the way, is 90 minutes. No, I love it. I thrive in this environment. It turns out I love this more than anything else. But as a result, so I've been probably speaking at every No Fluff event now for probably 11, 12 years, something like that. So I got to spend a lot of time with folks like Mark Richards and Neil Ford and Jeff Brown and a lot of like really smart people and really forward-thinking individuals. And I watched Neil Ford and Mark Richards' content evolve into their 2020 book, Fundamentals of Software Architecture. One of the things they did was they started evaluating the capabilities of all these patterns. And they came up with a star rating system. And the idea was, hey, something 5-star, just like a 5-star restaurant, 5-star hotel, 5-star resort, that's as good as it gets. Then you go to Dubai. I did a show in Dubai at the Burj Al Arab, and I found out that's a 7-star hotel. Well, who decided it was a 7-star hotel? They did. Oh, you just make stuff up, I guess. Okay, whatever. But they said 5 stars. That this architecture gives abilities or capabilities that are the best they can be. 1 star, you know, that's not particularly suited for that. So, and I have my 2020 t-shirt, 1 star, very bad, would not recommend. I guess it was kind of a weird year. You might have seen the news. I don't know. I don't know if it made it all the way out here, but in Colorado, it was a weird time. It was a weird year. But they came up with this scorecard. I thought this was a really cool idea, except there's a couple problems with this. What does 5 stars mean? You know, in our world, in the West, 5 stars means great. 4.5 stars means excellent. 4 stars means it's okay, and everything below that is crap. There's actually a great XKCD that summarizes that. And so when you look at this scorecard, it's pretty easy to see a clear winner. Well, look at all the 5 stars we have for microservices. So let's just build microservices. I've spent enough time in software architecture to come to the conclusion that anybody who really understands microservices would never willingly adopt that topology and approach and everything else. You do it because you have to, not because you want to. But that's not the story these stars are telling you. And this is the out of context trap that I hinted at in my introductory rambling early slide. The out of context trap, which is basically blindly choosing the option that has the highest score or the most features or the most stars on the scoring matrix or the most checkboxes in the feature matrix without the context of the problem being solved. And I'm pretty sure, by the way, this is why so much enterprise software that we are forced to use is garbage. Now, I'm not going to name names, but you probably could. And we're probably thinking of some of the same pieces of software right now. Because the people who buy it, they're like, we're standardizing on a project management tool. 4-letter project management tool. And it's got the most features in the matrix, so it must be good for everybody. They're the customer, we're the users. They have no context for what we're trying to do. They're just trying to cover their bases. And we're stuck with it. And we can do the same thing in architecture. And that's why I've got the Roy Fielding quote again in here for some reason. But there is an ocean of difference between the capabilities of something and its overall success. And I'm going to take a hard left turn here for a moment, because sometimes it's just easier to explore these ideas looking backwards rather than forwards. And not only that, it turns out that the metaphysics of software, how does it get these qualities? What are these qualities? I mean, you can go really navel-gazy, philosophical. You know, are we physicalists? Are we realists? Are we, you know, all these different schools of philosophy. So I'm going to choose something tangible that maybe 1 or 2 people in this room actually remember. We're going to look at a technology that, despite having a lot of capabilities that were superior to its competitors, it failed. Now, my all-time favorite movie, let's see if this works. It does. My all-time favorite movie is The Blues Brothers. John Belushi, Dan Aykroyd, fantastic film, and in my opinion, the only feature film that has any business being a musical. This is the only legitimate musical in my mind. I mean, when your cast is James Brown and Ray Charles and Aretha Franklin and John Lee Hooker and Cab Calloway, right? Yeah, of course they're going to burst into song. They're icons, they're legends. Now this, as you may or may not know, is a VHS cassette. This was the first format that I owned this film in. Now, VHS was the dominant media for... VHS was introduced in the mid to late 1970s, and it was the dominant media until around, I blanked it. It was the dominant media until around the late 1990s, when it was supplanted by DVD. If anybody's old enough to remember that shift, and we had to go buy all of our stuff again. And it makes sense, right? We get it, because DVDs were higher quality. DVDs were cheaper to produce. They supported things. They had extra features like chapters and random access and special features and additional audio tracks and digital audio, all these things. DVDs didn't wear out on every read like VHS did. I've never had a DVD player eat my DVD, but I've certainly had tapes get eaten. And DVDs didn't need to be rewound. Maybe that's what's wrong with society today, that we no longer have to be kind and rewind. But around the time that the VHS was introduced, there was a superior media that, despite being objectively better in many ways, it failed. I think I know where you're going with this. Oh, well, go ahead. You can say it. I do actually happen to have Blues Brothers on Betamax. Yes, I have this as well. So yes, Beta. Yeah, I have both. I actually own this on pretty much every obsolete media there is. But that's not what I'm here to talk about. I'm actually here to talk about something else. Laserdisc. Laserdisc. Also invented in the mid to late 1970s. And when we look at the feature matrix, there's a lot to love about the Laserdisc. First of all, the quality was slightly better. Now, the difference between VHS and DVD, 420i, 480p, so it's a little bit better quality. Laserdisc wasn't that much of a leap, but it was a little bit of a leap. So I'd say low to medium. And Laserdisc gave us things like that random access. It gave us things like access to chapters that we could skip ahead to instead of manually fast forwarding, scrubbing to find that scene where they go into Ray's Music Exchange in Calumet City, Illinois, no, wherever it was, in Illinois. It had special features, making of and deleted scenes. It had additional audio tracks. You could listen to it in a different language if you wanted to. And if you had the support, if you were ballin' back in the 80s, it had digital audio that would sound amazing in your super expensive system and interactive menus. And I'm looking at this. Everything Laserdisc had that VHS didn't. And I start to wonder, why have I never actually in my entire life, I've seen one Laserdisc in the wild my entire life. Why did it fail? Must have been money. Must have been just way expensive, right? And it turns out, no, the Laserdiscs were about half the cost of the comparable VHS at the time. It was big, sure, but this was what our LPs looked like at that time. This was a pretty familiar form factor at the time. I thought it must be the players. The players must be, because like lasers had barely been invented. So it must have been that. And it turns out, no, the engineering to make a VCR is way more complicated, it turns out, than a Laserdisc player. Do you know the bandwidth of a VHS tape? The bandwidth to store broadcast quality video on tape, magnetic tape like this, the tape has to move 12 miles an hour. That means for 15 minutes of recording, you need 3 miles. I can't math. I told you, I'm just cold. I don't even know what time zone I'm in. 3 miles of magnetic tape for 15 minutes of video. So we actually had to figure out how to move the tape that fast without having that much tape. So instead of the tape moving at 12 miles an hour, the read head moves at 12 miles an hour, and it scans diagonally. And so that's what we ended up doing to make this work. So this was really complicated engineering. Of course, now, later on, I mean, the VCRs got super cheap. But when these two formats came out, significantly cheaper. So you could look at this and say, oh, there's definitely a clear winner, but the market said otherwise. And at the time this movie was released, there was only one Laserdisc player being sold for every 50 VCRs in America. Why is that? And what it really boils down to is it didn't matter. None of this mattered because Laserdisc solved the wrong problem. See, the problem that we had in the late 1970s, early 1980s was not creating a library of video content. That's just not how we consumed video at that time. It wasn't something we thought about. That wasn't the problem that we had to solve. The problem that we had to solve was the way we are used to consuming media. And that was broadcast TV on a limited spectrum. which meant if you wanted to watch your show, you had to be at home, in front of your TV, tuned to the right channel at the right time, or you'd miss it. And it's not like today where we have entire sets of channels that do nothing but play the same series over and over and over and over again. Limited bandwidth, limited spectrum, limited options, limited licenses. Like for me as a kid growing up, one of my favorite shows was MacGyver. And I always tried to catch the new MacGyver episode. And if I missed it because my dad wanted to watch the stupid game, or I had to go to my sister's stupid recital, nobody should ever get dragged to a recorder recital. Like, that's cruel and unusual. And I would miss it. And that was it. Now, if you had like a knock you out successful show, maybe there'd be one more slot. But MacGyver was sort of, middling in terms of ratings and everything else. They weren't gonna use valuable schedule time to rerun the all new episode of MacGyver every week. So if I missed it, that was it. I just have to catch it on syndication. And the episodes usually just kind of got randomly aired. So every week I'd have to get the TV guide. Is this the one that I missed? No, it's the one where he seals acid with chocolate because it's a disaccharide that, you know what I'm talking about. Not a bad episode, that was a good episode, but it wasn't the one that I didn't get to see. And I used to watch the opening credits. And that was like my checklist of all the episodes that I had seen, because they're just little montage of clips from the show. And I'm like, okay, I got like 2/3 of the opening credits. But so the problem that we had to solve was time shifting. And it didn't matter what other features we threw into the media. If we couldn't time shift, it didn't matter. Now, later on, we start thinking, hey, we got all these players. This is my favorite movie. I'm going to buy it so I can watch it whenever I want. But at that point, we were all locked. We were all vendor locked. So we just bought everything on VHS. And, they made these. They didn't sell that many. They made these, but they didn't sell that many. And so the point is, having the most capabilities is not a guarantee of success. And as Mark states, if the architecture doesn't solve the right problem, the project won't be the success that it could be. So if we want to be effective, whether we are officially software architects, bestowed with the title, or you just have to wear that hat because that's just the way your company and your team is organized. You start to think about these things, not just what to build, but how to build it, how to structure it, how to take it apart, how to put it all back together. We better make sure we're solving the right problems. So holistic software architecture starts with this idea of solving the right problem. And something like microservices definitely solves problems, but they are not common problems. So for me, though, it means I don't want to have the architecture conversation until I have the business conversation. I remember when I joined that company I was telling you about, the when I was chief architect. At first, I was just an architect on the team. And I came in and I joined that whole team. And it was sort of I was really focused on a greenfield sort of startup embedded in the enterprise. And we had our first meeting. And I remember we had guys in Belarus, and we had people in Ukraine. I don't know if they get along anymore. I'm not sure how that shook out, and we had some people in Colorado, and I was in the office, and some of them were remote. We were hybrid, and I'm just sitting there kind of taking notes, trying to get up to speed. I said, so what are we building? And one of the Belarusians, a guy named Ignat, very, very intimidating man. I don't think I've ever seen him smile. And when I met him in person for the first time, he's like 6'10". And he's even scarier in person. He says, I'll send you the document. I can't do accents, so just bear with me. He says, I'll send you the document. And he sends me this like 250-page Word document. It's like laying out the patterns they're using, the technologies, everything, like lays out every architecturally significant decision. And I read it. Not exactly a page turner. Took me a long time to actually get that thing cover to cover. I printed it out, which was wildly expensive, by the way, because I don't own a printer. So I went to FedEx and printed it. I'm like, you might as well bind it. They coil bound it. It's like $150 to print this document out. And I'm annotating it. I got the little sticky notes on the edge to jump to different sections. I got annotations and highlights and everything else. And I read it. I studied it. I understood it. And nowhere did it actually say what we were building, just how we were building it. So we have the next meeting. And I said, so I read this document. And I have one more question. And they're like, oh, Michael's got another question. So what are we building? We're building that. Yeah, I understand. Like that's cool. This is exciting. This is something I can brag about at conferences. I'm in. But what are we building? That. No. Okay. Look. Okay. We build that, and I'm not an architect. I'm a user. What do I use it for? He says, oh, we don't know. The business, they're still kind of trying to figure out what it is that they're building. Somebody somewhere had a really compelling pitch deck, and the business gave them a $40 million budget. And let me tell you how this story ends. We spent $40 million. And I don't work there anymore, and my colleague who is the director of software engineering doesn't work there anymore, and nobody else on that team works there anymore. We spent $40 million, but had nothing to show for it, because we did everything in the wrong order. And since then, I remember us talking to that friend of mine, and he's got a new gig. I said, hey, Kevin, how's the new gig going? He says, yeah, it's going okay, but still haven't gotten the non-functional I rubbed off on him a little bit. And now he's thinking about requirements first instead of questions first instead of answers first. And he says, it's going okay, but I still haven't gotten the non-functional requirements from the business yet. And I said, yeah, you're going to be waiting a long time, because that is not how it works. They're not going to give this to you. You go ask the business, they're gonna give you their pithy vision deck that gets the investors all excited. They're gonna have a pithy one-liner. Oh yeah, we're building whatever it is, TurboTax for engineers, or the Uber of that, or the X of Y, whatever it is. It's like, okay, yeah, but what does it do? What problems are we trying to solve? How many users are we going to have? What's this going to look like? All these different things. We have to tease that out. So another one of these axioms that I have is this idea of fit, because the architecture has to fit, and not just the abilities, the capabilities. It has to fit the teams. The biggest problem that project had was we had an architecture that it evolved. I put my fingerprints all over it, and it started to fit the abilities that the business needed. And then we gave it to several hundred developers. It didn't fit them. And it was way too advanced. We went way beyond the skill set of that team. Now, these were smart people. Do not get me wrong. These were very smart developers. But their expertise did not align with what the architecture needed. There were all these additional skills. You take somebody who's, well, I'm a senior Java developer. Fantastic. You own your IAC now. Or what? Yeah. Well, we're running on a Kubernetes, because of course we are. Let's throw Kubernetes at everything. What? Kubernetes? No, just go read a blog post. You'll be fine. And so another one of these axioms, architectural fit, is the highest importance. And it has to be a holistic fit. It has to fit the needs. It has to fit the team. It has to fit the problem. It has to fit the capabilities. But the thing is, it doesn't always look the way you expect. Let's look at a case study. So imagine you get hired, and they say, you've been doing this a long time. You're our architect. Okay, sounds cool. I thought it was cool when they hired me to be their architect, and then they made me their chief architect. I thought, oh man, that sounded fancy AF. I'm just like, okay, chief architect. I like the sound of that. Turns out it's mostly just meetings. So many meetings, nothing but meetings. I don't know if I ever want to be a chief architect again. I've done it a couple times. That was enough for me. But you come in, they say, Bruce, you're the chief architect. We're a startup. We need to be agile, and we're going to go grow huge. We're going to be huge. So what architecture should we choose? Because that's your job. Which architecture? See, you're listening. You didn't walk into my little trap. I'll get you for that later. But, what are we going to do? Microservices, monolith? So maybe we qualify the capabilities. All right, well, our particular startup is the Web 2.0 wunderkind that was Twitter. May it rest in peace. And this is it. Twitter was launched in 2006. It had a set of features and functions that were a hit. And they were right. They did, in fact, grow huge. They grow huge very quickly. In fact, it didn't take very long for this to happen. The infamous fail whale. Now, what's really interesting about this is the screenshot of the fail whale that I was able to find was copyright 2012, 6 years after the launch. But it was right after the launch that we started seeing the fail whale because they were a little niche. You know, it was not that long after Jack posted his, this is my first tweet, or whatever his first tweet was. And then South by Southwest got excited about it, and then everybody's on Twitter, and then we started seeing this. We saw this for about 6 years. And the features were great, but the capabilities were lacking. Well, what did we need? Well, yeah, oh, hang on. Scalability, yeah, elasticity, throughput, fault tolerance, availability. And in fact, ultimately, Twitter spent about the next 7 years rebuilding everything to start to get these capabilities. So here's my question for you, because it was like a 7-year rewrite and redesign and re-architecture effort. Many, many years. So did they make a mistake at the beginning? Was the initial architecture of Twitter wrong? If you don't know, the initial architecture of Twitter was initially a Rails monolith backed by a MySQL database. Can you imagine running late generation Twitter on a Rails monolith with a MySQL database? Yeah. So was that a mistake? Was it wrong?
Not necessarily.
Not necessarily. It depends. See, now you can, now you can, yeah.
Because it allowed you to get to market quickly.
Bingo.
Test whether you're solving a real life problem that people would want to use Twitter.
And I'm going to repeat that for the people at home. Not necessarily, because it allowed them to get to market quickly and resolve, I'm paraphrasing, resolve market uncertainty to figure out if anybody was even going to give a crap about these features. This idea of microblogging was brand new, never been a thing. And, you know, they learned a lot. I don't know if you know this, but initially Twitter largely worked over SMS. That's why there was a 150 character limit, because it was constrained, because most people were following and tweeting on their phone, not this kind of phone, the candy bar phone, the Nokia. And it turns out, you know, right after that, the iPhone dropped and they had apps, and the whole SMS piece eventually went away. That wasn't the winning formula, but they could iterate very quickly to find that winning formula. My favorite little side story about that era of Twitter, by the way, was there was a guy who got the handle @Jesus, and it was once Twitter was getting a little bit of momentum, and suddenly your worth as a human being could be measured by how many followers you had. The guy with the @Jesus handle, he just started a little viral campaign. He just, you know, started making the early memes, these little pictures that got shared all over the place. I don't know if you ever see these things on Facebook or any of these other decaying social media sites that exist today, where it's like, I bet nobody's gonna respond amen to this post, and then you get all these amens on there, and, you know, engagement baiting, things like that. His was text follow Jesus to whatever Twitter shortcode was. And all these well-meaning boomers, like my parents, I think my dad actually followed Jesus for a little while. He had no idea. Probably fine. Something's beeping. Probably fine. I was giving a talk in California once. Ah, okay, that's not so bad. I was giving a talk in California once, actually for JetBrains, Kotlin Conf. And they said, by the way, just to let you know, there might be an alarm go off. The carbon monoxide sensors have been going off all day, but don't worry. And then somebody else says, oh no, don't worry, we just disabled all of those. So it won't be interrupting your talk. Well, that's a relief. Glad we dodged that bullet. I was wondering why everybody was going to sleep in my talks. But yeah, my dad actually followed Jesus for a while, and he was like, "Why do I keep getting these texts?" I'm like, "Because you're following somebody on Twitter." So what's Twitter? I said, "No, I have a rule about technology conversations with my dad. Maybe I'll tell you that story later. Maybe it'll be after, maybe not when we're recording. I'll tell you some other stories." But that's the thing. Version 1.0 was designed for a certain set of capabilities that would deliver the highest business value in that moment. And the fact that it was successful allowed them to get a lot more funding, a lot more investment, because people are like, okay, this is definitely cool. Let's invest in it. Let's scale it. Let's do it. And then they built version 2. Version 2 was designed for a different set of capabilities. And there would be no version 2 of Twitter if there hadn't been a version 1. And that's the key thing. Every decision is a trade-off. This is the first law of software architecture as described by Mark Richards and Neil Ford. You might be wondering, what are the other laws? The second is why is more important than how, and there isn't a third. Because I spent a lot of time with Mark and Neil, and they were working on this. They're like, yeah, we want to come up with the laws of software architecture. I said, what do you got? They said, everything is a trade-off. I said, oh, what else you got? Well, that's it so far. But they wanted to come up with like the 10 commandments of software architecture. And eventually they got a second one, why is more important than how. There's also a corollary to the first law. The corollary to the first law is if you think you've identified an architecturally significant decision that isn't a trade-off, it is, you just haven't identified the trade-off yet. Because they would say this in conference talks and I'd be sitting in the back heckling from time to time. And somebody else would heckle too. They're like, but what about this? What if we do this? That's not a trade-off. Aha. And then Mark or Neil would say, well, what about this, and this, and this? And the person would be like, oh. So the corollary is if you think you've identified a trade-off, something that doesn't have trade-offs, it is still a trade-off. You just haven't identified the trade-offs yet. So that means to do this and do this well, we have to infer the capabilities from the business. Because V1 and V2 of Twitter, they traded certain capabilities that made sense in a given context. V1 fit in the beginning and then it didn't. And V2 fit. Now, the way they did it, it was a very complicated effort. It doesn't have to be. Architecture doesn't have to be the stuff that's hard to change. Architecture can be agile. This is what I discovered putting this model together, that it's actually really easy to evolve architecture if you design it to be evolvable. In the same way, it's really easy to tailor clothing if it's designed to be tailored. So, of course, a lot of this stuff requires practice. This is not something that's going to come naturally to most people, especially if you've got a developer background, right? Talking to the business people, listening to the irritating business speak and trying to read between the lines and infer all these things. It's like jazz. You got to listen to the notes that aren't being played. So coming at this idea of holistic software architecture, I came up with a list of problems. The first problem is this: how do we more accurately determine problem fit for a given architecture? Well, we have that business conversation. Now, alternatively, we could just go find a list of abilities, go to the business and say, hey, here's a bunch of capabilities that the software can have. Which one of these do you want? Or which of these are important? Whoa, that right there, that is a trap, and you walked right into it, because they will say, oh, we'll have all of those, please, which you cannot do. There is no golden architecture that is simultaneously good at everything. We have to translate these things. As my friend Nate Chuda says, we're the organizational Rosetta Stone. We're the nexus of all these different actors in the organization. Product owners and business people and finance people. We've got to speak their language. We have to speak finance to the finance people. We've got to speak business to the business people. We've got to speak technology to the technologists. So we translate these into technical requirements. And I've got a whole chapter that just gives you a blueprint, gives you scripts to follow to have these conversations. It really boils down to the preparation you do in advance, figure out the questions that you need to ask. start to enumerate some assumptions and then test those. You're inferring requirements, you're identifying these stakeholders, and then you're talking to them. And you're finding out where you're right, where you're wrong, and where you're off by a few degrees. And then we've got to validate these. We have to qualify these capabilities. We have to quantify these capabilities and document. And of course, it requires new tools and things like that. And that's why, that's the reason that I wrote the book, is because a lot of this stuff we already know, but it's how do we fill in the gaps? And how do we fill in the gaps in a unified way that doesn't require all of these, that doesn't require decades of experience, just, enough experience. And then we have to start going into the trade-offs and figure these things out. So let's assume we've got some kind of example project, and you're at the beginning of all of this, and they give you their vision document. Look at all these words. In today's fast-paced digital environments, contextualize, connect data, turn into actionable knowledge. I don't know, you don't actually have to read this. I mean, if this was your project, by the way, this is not a real project. I'm told by my attorneys that this is legally distinct from anything that has ever existed before. So I can definitely throw this into my talk because it is legally distinct. But in our example project, let's say we look at all of this, right? And we pull out all these capabilities and we prioritize them. We've qualified these. We've ordered them. So we know the order in which we trade off. Yeah, we can flex on cost to a point. Turns out if you spend $40 million, you have nothing to show for it. Not that those two projects were related by any stretch, but hypothetically, for instance, right? Maybe we could flex on cost a little bit, at least to a point, to make sure we got the right evolvability, because we're trying to figure out what we're going to do with this brand new thing. Now, if we look at these, even if we just look at the first, 4 or 5 of these, we go to the scorecard. You're like, okay, which architecture should we pick? Which one aligns? Well, there's capability 1, there's capability 2, there's 3, there's 4, there's 5. Fantastic. Well, we look at the first one. Now there's our winners. And then we look at the second one. Now we could do the old orchestration driven. We could bring back ESBs and SOAP. All is forgiven? No, probably not. So we'll take the second best. Oh, there we go, back in microservices and event driven. And we do it again. No, thanks. We'll go back to microservices and event driven. Then we go look at our agility. There it is, 5-star agility. It's going to be fantastic. And what about, event driven kind of works too. Maybe we'll consider that. And then testability right there. There it is, testability, 5 stars. That's, it's not a perfect fit, but it's pretty close. Now, what I like is we're not limited in this manner anymore with this new model, but, we're starting simple. And I guess service-based could work there on the testability, but we've got a winner. There it is. And if we look at the scores, boom, there they are. There's the scores from the microservices. But here's the interesting thing. First time I showed this slide in a conference talk, there was a guy sitting right about where you were. And he's looking at it like this. Kind of tilting his head to the side, squinting. I could tell, like the wheels are turning. So I said, you have a question? He says, yeah. Are those scores widely accepted in the industry? And I thought that was a really insightful question because it points out that these are rarely absolutes. Your mileage will vary. In fact, it almost certainly will. And I can't tell you the number of people who have built microservices expecting this, but they got that. And you have to ask, but why though? Because breaking an application up into hundreds of pieces does not magically make all those capabilities appear. It feels like a crapshoot. Software, I forget who said this. It's a great quote. I forget who said it off the top of my head. Software and cathedrals have a lot in common. First we build them, then we pray. And so the second problem, how do we get more reliable in here? How can architecture be more deterministic? Because right now, the way we approach architecture, it's a crapshoot. We build it, and then we find out all the ways it's not working the way we thought it was. It's not working all the ways the books and the people at conferences told us it would. And then we got to figure out why. We have to figure out how to adapt. And a big problem is this third thing that I mentioned in my preamble, the flat taxonomy problem. Because really, we have a regrettably narrow taxonomy of software architecture. We got on one side, we got the monoliths. And on the other side, we have the distributed systems. Whoa. Now, first of all, I've maybe worked on one monolith my entire career because there are always distributed components, whether it's client server, whether it's the database, whether it's something else. But aside from that, so like most monoliths are actually distributed. Beyond that, what do these things even mean? You find 100 people who have worked on 100 different microservice projects, and you're going to find at least 100 definitions of microservices, because what we end up building is always going to be different, especially once we deploy it and find out that our scores didn't align with what was promised. And it's because, but what happens though, is all those different systems that we call microservices, we call them that because we don't really have good definitions. We go down to the lowest common denominator, the topology. Oh, it's got a bunch of independent services, microservices. No, it doesn't matter if, you know, one of your components, one of your distributed components in that system spans 15 different domains. It's a distributed system, so it must be microservices. And but we associate those capabilities with the topology, not the decisions that led to the pattern in the first place. So like I said, breaking an application into hundreds of tiny pieces does not magically make all these things appear. In the same way, having a monolithic component granularity does not presage a big ball of mud. There's no single correct set of decisions. And what's worse, you read a book, you're going to get one of two things. Either you're going to get a book that is prescriptive because somebody somewhere, Netflix or wherever, Google, I don't know, they built microservices and it worked for them. And it worked really well. And they're going to say, I've cracked the code. There is a silver bullet. Build your microservices exactly like we built ours at Google, except none of us are Google. And the other ones, but we like it because it gives us the easy answers. And the other ones are a little more nuanced and say, hey, here's all the decisions you have to make. And that's hard. But as an architect, maybe you'll do your due diligence. You'll read Sam Newman's book. You'll read Eric Evans' book, and just make sure you read it in the right order. I foolishly read it front to back. I met Eric Evans last year at Explore DDD. We're having dinner, and I said, by the way, I have to admit, your book occupies a position of shame on my shelf right next to Infinite Jest and all the other books that I've never finished. And everybody at the table starts laughing. And they said, what order did you read it? And I said, sequentially. And they're like, oh, yeah, no, you're supposed to read it section 1, section 4, section 3, section 2. I'm like, of course, why didn't I think of that? But maybe you'll do your due diligence. But then you got hundreds or maybe thousands of developers that have to implement your design. So as soon as you say microservices, then they're just going to say, oh, okay, cool. They're going to look at everything that they've been told was microservices, which are always different. And they're going to say, we're building microservices then. Got it. And you wonder why you can't put Humpty Dumpty back together again. This is why, I'll say it again, patterns aren't architecture. They're a side effect of architecture. Because we're talking about this topology that is heavily overloaded. You know, we got used to patterns in our industry as high bandwidth ways to communicate an idea. But that only works if we have shared definitions. And the reality is, at any meaningful scale, there are no shared definitions of these broad overloaded labels. In fact, let's look at one capability, for example, evolvability. The ability for a system to gracefully adopt and absorb both business and technical change. Supposedly, this is very good for patterns like microservices, and it's not great for patterns like the monolith. Except we build microservices that are, and we build microservices that aren't. We build event-driven systems that are, and we build event-driven systems that aren't. We build monoliths that aren't. We build monoliths that are. It's the magic is not in the pattern. The magic is in the decisions that originally defined the pattern. So we got to move away from pattern-driven architecture towards decision-driven architecture. I'm getting old. I can't keep up with the memes anymore. This is like, for me, this is cutting edge. I'm just saying. I see you're pretty young. And you're like, who's that? But I don't mean to call you out. But you are young. You're fantastic. You're going to get to enjoy more of the future dystopia than me. You get all the fun things. But let me look at it this way. Every decision in a project, every project consists of a number of decisions. Now, if this circle represents all the decisions that are made in a project, there exists a subset that directly impact the capabilities and their measure. And actually, since we're on the subject of outdated memes, what if I told you that there is a way that these key architectural decisions could be codified into atomic building blocks that you can piece together to induce certain capabilities in your system? Rather than starting with the pattern, you can derive whatever it is that you need. And by composing architectures in this way, you can actually get deterministic outcomes. Well, we have to answer the question, where do capabilities come from? And I'd love to get into another long philosophical discussion of metaphysics of software, but I'm going to keep it simple. Architectural capabilities are induced by constraints. By constraining the degrees of freedom on the implementation teams, we get capabilities. And a simple, tangible example of that is the solid principles. We know them, right? Single purpose. We're constraining the system to be single every class is constrained to have a single purpose. And if we just look at maintainability, as soon as we add that constraint, our maintainability goes up. And then we can look at extensibility and testability. Well, as soon as we get into the open-close principle, these things improve. Again, we're constraining the degrees of freedom. Yeah, open for extension, closed for modification. Liv-Scott's substitution principle. Yep. Hey, this is, yeah, I love it. Interface segregation. Yep. And then we look at interface segregation, how that affects adaptability and testability. And then if we just look at our testability again, we have a dependency inversion, our testability goes up. So solid principles, call them whatever you want, standard operating procedure, best practices, anything like that. But it's really just a set of constraints that take you from neutral to improving these capabilities. Now, it's because you take these away, you get a big ball of mud. That's what defines a big ball of mud, is there are no rules. It's a free-for-all. You can do whatever you want. Make everything global. Go for it. You want a 30,000-line God class? Have 5. The world is your oyster. Where is your God now? Anything. That's how you get a big ball of mud. That is, if you read Joe Yoder and Brian Foote's paper, like that's the definition. A sprawling, sloppy, duct tape and baling wire spaghetti code jungle. I'm paraphrasing, but that's more or less how they described it. And you can get the identical functionality with constraints on the degrees of freedom on implementation, and you go from there to there. And this is not a new idea. In fact, I mentioned Roy Fielding. How many people read Roy Fielding's dissertation? Right? Part of it, yeah, chapter 5. Yeah, you did one of these, chapter 5. Yeah, because chapter 5 is where he talks about rest. And it didn't help at all, did it? Because that's not what the paper was about. It was never about rest. It's in the title, Architectural Styles and the Design of Network-Based Software Architectures. REST was just the example. REST was the architecture of the World Wide Web. And he defined the REST architectural style, the architecture of the web, a phenomenally successful software system that is over 30 years old. We never had to stop for a rewrite. We never had to stop for a re-architecture. It evolved in ways that nobody anticipated. It scaled in ways that are unmatched. It went from one machine in Nextcube in Tim Berners-Lee's office to the entire planet. And it just keeps growing, and it just keeps changing. And the whole idea of this paper was architectural design by constraint. And if you read that paper, he didn't invent it. This idea of constraints starts with the mythical man-month. Tower of Babel, why did it fall? There were no constraints. Foundations for the Study of Software Architecture, Perry and Woods, 1992, heavily cited by Fielding's paper. And then in 1996, Shaw and I forget who, Software Architecture Perspectives on Emerging Discipline. Fielding's paper, 2016, Tibber, Messine, and others. I can't pronounce any of the names, so I'm just going to say et al. Software Architecture Constraint Reuse by Composition, 2023, that found its way into the architecture model. The idea is not new. And the idea of connecting constraints to capability has been shown to work over and over and over again in theory and in practice. And not only that, there was a thing in Fielding's paper. He said, now, in theory, because each one of these constraints has a measurable impact on the abilities of the system, the capabilities, in theory, you could weight these numerically. And when you apply a constraint, you could quantify what's going up, what's going down. He said, but unfortunately, that requires somebody to define all these things and then give them some kind of scoring system. And I'm not going to do that's not the subject of my dissertation, so I'm not going to do it. But maybe someday somebody will. Then Ford and Richards scored everything. And they put it in a book where they concretely defined the definitions of these patterns they were talking about. And now we can do that. The constraints can be weighted, and we can get design time feedback. And because we're not just using vague, overloaded terms for patterns, but we're defining our architecture by the architecturally significant decisions that make the architecture do the things that we want it to do, we get a more deterministic outcome, and we can communicate these things more clearly. And so what I found out is when you change the way you look at things, the things that you look at change. Now, these are all different in terms of topology and granularity and how things communicate and module boundaries and persistence and code reuse and everything else. But when you look behind the curtain, they're really just different combinations of a handful of constraints. These are some of them. So we can do more though, because now we can actually start asking the right questions, look at the right primitives. So if you look at our example project, maybe we score it based on the 5-star scoring model. I don't use the 5-star scoring model. One, that's their model, not mine. The other is the stars don't tell the whole story. Like if you read my book, there's a much broader range from extremely high instead of 5 stars, because we all want 5 stars, but we all don't need extremely high scalability. Like Amazon does something like 158 million during Prime Week, peaks out at something like 158 million requests a second. That's cool. I don't need that exactly. But I want 5 stars, but I don't necessarily need extremely high scalability. And the other thing was 1 star can mean terrible. 1 star can mean okay. Shopify has a monolith. The Shopify's a monolith. Their architecture is a monolith, and they're proud of it. And they're like, yeah, we're not gonna decompose it. Agility, 1-star agility for Shopify. It's 40 deployments a day. 40 deployments a day. That's 1 star. Most projects I've ever worked on, we'd be lucky if we got 2 deployments a month. And we call ourselves agile, but mostly because we want to be buzzword compliant. We want to be able to check that box. And they're still in like 50 million requests a second. Like Black Friday, Cyber Monday, their platform is like 50 million requests a second. Something like that, or I forget, 1.2 million requests a second, something like that. That's still amazing. 1 star is what we call that. So mine goes like extremely high, extremely low with a bunch of spots in the middle. But if we look at it this way, and we redefine the pattern not by the topology but by the constraints, and we score it, we're going to end up somewhere around here. And that's not bad. But the first thing that we can do is now we can start to move these lines, not in big discrete chunks, like going from one pattern to another, but by just adding or changing constraints. Like workflow here is really important. We're terrible. But we can, start to think about, well, what's the constraint that's going to improve this? So we take lessons from event-driven architectures. Okay, well let's bring in PubSub as our data backplane. Boom, our workflow capability blows up. Now we have hybrid microservices, sort of event-driven microservices, a little bit the best of both worlds, as it were. And we've improved a lot of different things. Now we got another one. we can solve this with more constraints. How we're representing our data, how we're connecting our data. And so we can bring in the resource abstraction and the RDF data model, semantically defined data, which allows all of this diverse data to start to connect. That's a whole different conversation for a different day. But we solved that problem. And the other thing, one of the requirements, if you read that whole thing, there was a requirement for a knowledge graph. When you do this, a knowledge graph just falls out. It just appears. You just get it. And so here's the thing, though, architecture is more than this. Because, and I kind of alluded to this already, but in 2017, about 3 years after Martin Fowler said, hey, these microservices, they're amazing. In fact, here at ThoughtWorks, a lot of my colleagues are just using as default architecture for everything we do. A year later, he posted another post on his blog that said, don't start with microservices, even if you think you're going to need them. They learned a lot in a year at ThoughtWorks. But, and then a couple years after that, Gartner said, by 2017, 90% of the organizations that try to adopt microservices will fail. They'll find the paradigm too disruptive, which I thought was hilarious, by the way, because Gartner was unironically living and embodying the Gartner hype cycle. Because if you read their previous prognostications, they were like, microservices are going to be everywhere. And then they're just like peak of inflated expectations, trough of disillusionment. And in fact, we saw this a couple years ago. There was a very high profile, this is a misleading headline, and I'm not going to get into the minutia of it, but they're not a panacea. Despite the capabilities, microservices don't always fit. And the reason that this is successful sometimes was not a realization that tiny components were a panacea. It wasn't one of these ideas that was waiting to be discovered. If you went back in time, I have this fantasy about going back in time and like with everything that I know now and being hailed as this visionary. Imagine I went back to like 1998 and I start speaking at architecture conferences and I say, I have a great idea for an architecture. It's called microservices. And I lay it all out. People would look at me like I was crazy because what I said was crazy. It wasn't a radical idea. In 1998, it wasn't possible. A lot of things had to happen. There were X factors, right? The influence of the Agile Manifesto, a call to the industry to embrace change. We had emerging practices and their influences like Kent Beck and TDD and all these things. Continuous integration, continuous delivery, the rise of DevOps. And then when we needed these kind of modular architectures, we needed to figure out where to slice them. And we knew about Conway's Law since 1967, but we didn't have a practical framework until 2003 when Eric Evans published Domain-Driven Design. So these are constraints too, but these are constraints on us. They're constraints of a different kind. So when you look at microservices, what do we need to build these? What is required? What are we constrained by? Well, if we're going to slice along the bounded context, we need to know where the bounded context is, which means we need well-defined domains and an investment into DDD. We need to learn what Conway was talking about, that organizations that produce systems, whether they're software systems or communication systems or whatever else, they're going to mirror however you communicate in the organization. In other words, it doesn't matter what you design on in Lucid chart, you're going to ship the org chart. So we need domain-aligned teams, and we need sophisticated dev teams that can understand why you're saying, hey, that dry thing that has been beaten into your entire career, yeah, we don't want to do that anymore because that's creating coupling that's going to constrain our agility. So please repeat yourself. Reuse is abuse. And a lot of developers, they like it's foreign. You're telling them that Santa Claus isn't real. It's a hard thing to come. So you have to be sophisticated enough to understand the trade-offs. You need very mature development process. You need high automation in dev. You need organizational commitment to DevOps, organization-wide. Everybody wants to be buzzword compliant, and usually that just means taking the operations team and renaming it to the DevOps team. And they're like, hey, we're doing DevOps now because we renamed the ops team. Okay. But usually those same organizations, when there's some hot fix, some red flag, red alert kind of thing, and they're like, you demo the fix, and they're like, why isn't it in prod yet? Well, the tests are failing. Well, you just showed it to me. It's fine. So just ship it. Just disable the tests. We'll temporarily disable the test, and we'll fix them later. Yeah, exactly. That's the right reaction. Temporary means permanent. Later means never. I've been on this road before. You need team independence. How many times have I seen when I've come in to do rescue projects where the things just start, all those 5 stars aren't magically appearing, and it's because every team is dependent on everything else. Their whole process is coupled. It's like, well, I can't ship my microservice until they finish theirs because I have to call theirs, and they're still working on their API. And then, of course, they're integrating in dev, and it's like, okay, everything's working, cool, ship it. I'll ship my microservice. And then I find out that what that other team has in dev is not what they have in prod, and everything breaks. I have to roll it back. And before you know it, you don't have independent deployability. You have monolithic deployability. You have a distributed monolith, which is the worst of both worlds. We have to have the pipelines and the automation, high operational automation. And so we have to think about fit. Years ago, I got sucked into the world of men's haberdashery. It's a long story. I'm not going to get into it. I have too many long stories as it is. But when I was a teenager, I worked at a company called the Savoy Tailors Guild in London, and I was a whatever. I'm not a tailor. I was like a consultant. I had a little tape measure around my neck, and people would come in, and they would ask me if they'd say, "I want a suit." Usually, they come and say, "I want an Armani suit." If they didn't know suits very well. If they did, they'd be like, "I want a Xenia suit." Okay, no, what you want is you want to look like $1 million. Let's figure out how to do that. And that's where the fit comes in. So we have to think about architectural fit, not just in terms of capabilities to the problem, but does it fit the teams? Does it fit the organization? Does it fit the business goals? Does it fit the current business climate? Is it tailorable to adapt to the business future? And so we have to fit across all of these dimensions, and our current architecture models don't help us here. It's just decades of trial and error and architectural intuition, but it can be codified. And so fit is more than aligning capabilities to the business needs. We have these non-architectural constraints that we're talking about. These are team constraints, organizational constraints, and environmental constraints. They're constraints on us. They either constrain us or we have to change these things. It's a whole lot easier to be constrained than change the entire organization. That is really hard to pull off. With our teams, we've got to think about a lot of different things, right? There's a lot of things that are going to undermine what we're trying to get the teams to do. With the organization, we have to think about budget. We have to think about timelines. Do they have well-defined domains? Do they have domain-aligned teams? And the environment. We have to think about the complexity of the solution space. How much sway, how much political capital do we have? How mature is our infrastructure? How mature is our deployment process? How open to new ideas is the organization? Do we have these autonomous development environments? And the next problem we have is, even if we follow this, if we design a good architecture, it has to be understood. People have to be able to execute on it. That's part of that holistic piece. So this is where, so how do we fine tune it? Sorry, how do we fine tune it? Well, we talked about how to do that, but we have to look holistically. And so every single constraint that we have now defining this architecture, we can directly connect to the team organizational environmental constraints. Because every single one of those constraints, you pick one, and I will tell you what is required of the teams, what is required of the organizations, and what is required of the environment. And now we can get in front of these microservice mega disasters and everything else because, and I'm going to be honest, I had to fail to figure this out. Like, you look at this, and then you look at this. That architecture is going to fit about as good as that suit. And if that kid starts trying to run, he's going to trip over those coattails and fall flat on his face. Ask me how I know. But we can find a better fit at design time because we can start to connect these things. So, maybe, we're overprescribing, we're underprescribing in some areas. But this constraint-driven approach allows us to move these around like faders on a graphic EQ, like a mixing desk. But we have to think holistically. We have to balance our constraints. We don't want to overprescribe. We don't want to under-support the constraints. That's the other one. You can't just from your ivory tower say, here it is, go figure it out. What, you haven't read all these papers on ontology alignment? I did. It wasn't that hard. Yeah, you have like real things to deliver, and I just get to deliver diagrams, but box and line charts, but you'll figure it out. Get, how to communicate, how to get the buy-in. How are you going to support these things? For me, every constraint that I prescribe has to be supported, and there has to be enforcement mechanism. And I don't mean sitting there standing over every single developer's shoulder. No, you done have it, son. Do it again. I can't do that. Like, I can't be everywhere all the time. And we just have to ask these questions and also think about that learnability. So the last one, and we're going to wrap up, if you've got a heavily tailored architecture that started with one of those patterns and then you tweaked it to be something that fits on all these dimensions, how do you describe it? Because yeah, we've got some kind of distributed, medium-grained, you call it a service-based architecture if you want to, but that means different things to different people. But we can't just call it microservices or event-driven or anything like that because those labels are so overloaded. But what we've done is we've created a new architectural style. And an architectural style, as defined by Fielding and Perry and Woods and everybody else, is a named coordinated set of architectural constraints. And so now we're no longer constrained to a handful of patterns. What we have, you're not trying to fit every single business problem into just 8 sizes. You have an entire universe of possibilities. And when I have a custom architecture that is defined by a set of constraints, it's a new architectural style that I get to name and describe. I write an architectural style document. This is based on an architectural style document that I've written. And there's a lot of links in here, links to ADRs, links to implementation guidance, links to training, links to everything the team needs. So we've got to wrap it all up. But I hope you can see this is a powerful way to think about software architecture. And I've just scratched the surface. Because as soon as you start looking at architecture that way, evolving architecture is not daunting anymore. It doesn't have to be a 5 to 10 year rewrite or anything else. You can, and we don't have to over-engineer up front. We can evolve, we can tailor as we go. The whole thing changes. And it looks like they're just about to give me the hook. I see you standing there in the wings with the microphone like, he better wrap it up. And so with that, oh, okay. Well, with that, I will say thank you. And I hope to see you at the Gateway Software Symposium, April 4th and 5th, right here in the Lou. Hopefully it won't be snowing. Thank you. I think we're ready for questions, or however you want to do it. I don't know. Or, I also just brought the deck of cards.
Well,
so
I have one quick question. What do you think about documentation and the importance of documentation to a project?
I think documentation, okay, I'm gonna preface this. Documentation is my least favorite thing. Period. I hate it. But I also think one of the most important things that I do, and something I will never pencil whip, is things like my ADRs. Because for me, an ADR is like the dojo where my ideas battle it out. Because I have biases, we all do. And they show up in my architecture, so in my architecture decisions. So when I write an ADR, I'm not just capturing what the decision is, when it happened, the context and everything else. I'm covering everything. What is the problem? What is the context? What are the options? What are the pros and cons of each option? And why did we pick what we picked? What are the positive outcomes of the decision? What are the negative outcomes of the decision? Because there will be both. There is always trade-offs. And I do that for a couple of reasons. One, it forces me to evaluate things that maybe I just kind of want to hand wave over because I have biases. But second, every decision you make as an architect will be challenged. And I love being able to come back to the dev teams when they say, oh, but if we do it this other way, it's going to be faster. I know. Yeah, we're incurring a performance penalty for evolvability. And in fact, I looked at that. Or why aren't we using this other thing? Well, we evaluated it, and here it is in this document that went through all the pros and cons of everything. And here's the context. Here's the problems we need to solve. And here's why it didn't quite line up. And then I don't have to relitigate every decision with every team. So I think documentation is important. That's one of the regrettably longer chapters in the book.
And it's equally important for the designer as well as for the implementer, saying,
Yes.
I implement it this way, this is my API, this is the way you call me, this is the way you get things done. Or get me to do things where you want me to do.
Yeah, I think to the extent that there is value with, especially with that level of documentation, to the extent that there is value, like, you know, like documenting everything is kind of like getting 100% code coverage. You can do it, but you're hitting diminishing returns. But I think it's figuring out what, and you can get to that what by starting with the why. Question. Microphone is coming to you. He's getting his steps in.
Thank you. So I'm not sure if I asked you this a year ago or not when I first heard you give this presentation, but how do you think some of this lines up with Philippe Croyton's 4+1, or like to think of it 1+4 architectural views? Kind of feeds into your documentation question. The idea being, he calls them logical, physical, process, and development, I think. And I like to think of them more as features, capabilities, deploy or delivery, and then operations.
Yeah.
Together by what makes us be here in the first place, which is, why am I building this system? What is it supposed to do?
Yeah. No, I think we're taking different approaches to solve different slightly and overlapping approaches to solve the same set of problems. So I think you know, if you were to go and like take this model and then if that's something that's kind of familiar to you in a mental model that you have, then that's just going to inform your approach with this. You know, it's you know, it gives you additional perspectives on the problem. And I think that's the key thing is coming up with not a checklist, but just starting to think about looking at the problem from different perspectives, because you will be very uneven in your efficacy as an architect or developer, senior developer that has architecture responsibilities, whether you have the title or not, if you're not doing that. So similar goals to bring top of mind the things that may not be immediately visible to us. But I don't have like a precise mapping, but I think you're doing the key thing. And this is what makes like breadth of experience and knowledge and mental models so valuable in architectural roles, because what you'll ultimately do is you're going to do, in the immortal words of Bruce Lee, absorb what is useful, reject what is useless, and add in what is uniquely your own. And I think that's the secret sauce for software architecture.
I think that's the last of the questions. So let's thank the speaker one more time.
Well, thank you.
And I'd like to suggest to those who are present to stay around because we're going to have a raffle. We have 2 JetBrains licenses. We have 2 Manga ebooks, and I think you volunteered a copy of the upcoming book.
Let's do 2 copies.
And you have to be